Hello everybody, this video is about the variable importance. In case you have your output data and some predictors as input, and you would like to know which ones of the input variables have the impact the most your output to continue your analysis. So the information about this you can find it in this article. I took some part of it from here, so it's helpful to apply for some research. So this is the data on which I applied the technique. I call it my data. I load it. My data equal read date table. I load it and try to see what is in it. Head parenthesis my data, and I have a discharge, the river discharge. The river discharge I would like to work on, to analyze. So this is my output or response variable or the target. These are the inputs. I have the time, but I am not interested in the time, but I'm interested in the climate and the terrestrial variables such as soil moisture, soil temperature, air temperature, evapotranspiration, specific humidity, and precipitation. So this is the overall situation, content of the data. If you like the correlation, you can just go with core because it doesn't have any character, so normally it should be. Okay, let's come to the topic variable importance. This one in case you have some characters. So these are the basic packages we need to install for anything. That's what I do here with my work, but these are needed because the first we need is the nnet, and we use nnet because we are dealing with the simplest case that is based only on one hidden layer. So in case you have just one hidden layer, it's very simplest case, we use the library nnet. So we install those four dev tools: nnet, ggplot2, neural net tools. Already install them. Once we install, we need also to call them. So we select everything here and run. Okay, all the libraries are called now, and I would like to make my work reproducible. So set.seed 1 2 3, you can change as you want. And this is my model syntax. Model equal nnet, the library used, and I have my discharge. We write with delta like a linear regression, and we try to predict over AT plus P plus ET plus SH plus SM plus ST. We give the size, the line out true, and the data is my data, the trace false. You can change those parameters and see the changes. So it's on my data. Set the seed. Now we run the model. The model is run. Now we plot, write this code, plotnet mode. This is going to give us the neural interpretation diagram, or NID. It gives you an idea. So this is our neural interpretation diagram. cut here. This is the discharge, these are the inputs. Let's change here, see. I'll put this the width 1000. The height generally is 491. It doesn't go behind that, but let's see. 5,500, sorry. Update. Okay, so this is what we have as our neural interpretation diagram. The black connections here mean positive connections or positive association, while the gray connections here mean negative. So you would have generally the strong dark or strong black. Sometimes it's not too strong, so it means that you are going from positive to strong positive. Like here you have positive, these are strong positive. This is not gray, this is also black, and this the width make the changes, make the difference here. So you see this one, H1 to our output is positive but not strong. The association was not strong, while you compare these are really strong. So let's come here. You see here, out of 5 connections we have here, the air temperature has 4 that are strong, 4 black against 1 gray. So the degree of association between air temperature and the river discharge. You come to precipitation, you have 2 black, which means positive, and the gray negative association. You come to ET, ET have 4 out of 5 positive association. Specific humidity has 3 out of 5. Soil moisture has 4 out of 5. Soil temperature also has 4 out of 5. So from here already you would have an idea about which of these input variables are really important to the discharge. We can say already soil moisture is important, soil temperature is important. We can also say ET is important, and the AT also is important. So this is how you interpret. If you like to take your image, you copy it from here, otherwise you cancel. The next step is to use the Garson algorithm. The Garson algorithm gives the importance of each variable, but doesn't say exactly the sign. So you type Garson mode for this model, and it tells you it's going to give us a plot like this. So you see the importance here, and you see each input variable here, which ones are the most important. So from here you see that ET is the first most, and then you see soil moisture and precipitation have almost the same. Precipitation is a little bit higher in importance, and then you decrease to the soil temperature. So if you run again, it may change because it's not stable, so the order may change. Let's run for the second time. You see, you see, okay, I'll come to the model discharge. Okay, now it changes soil moisture. With this, we don't have the signs, but we have the magnitude. When you use the Olden method to have the plot, you will have the signs and the magnitude in case it's positive or negative. So you have here with Olden All done tells us here that everything is positive. So it gives the same, almost the same result as the garrison we run. For the second time, we saw that soil moisture is the most important. And here also it tells us the soil moisture is the most important, followed by precipitation. So for the river discharge, these are the most variable we can consider to predict or to work on the further analysis we would like to do. So it gives an idea about selections, like a variable selection method. Instead of working using all the input variables you have, use these methods to have an idea about the relationships you have in a very selective way before going to the next step. So thank you for watching. I hope it helps you to manipulate your data, to process and pre-process your data before you go and spend more time doing advanced researches, focusing on just the right information. So this is a very important method you may need to consider while you are working on your data. Thank you for watching.